Good day, students. Welcome to this JSS 1 mathematics lesson on the properties of triangles. The triangle is the most fundamental polygon. Every other polygon can be divided into triangles. Bridges, roofs, electricity pylons, and the design of many traditional Nigerian structures use triangles because of their inherent rigidity and strength. Understanding triangles deeply is essential for all future geometry. By the end of this lesson, you will be able to classify triangles by sides and by angles, state the properties specific to each triangle type, prove that the angles of any triangle sum to 180 degrees, apply the exterior angle theorem, find missing sides using the properties of special triangles, and solve examination problems involving triangle properties. Let us begin. A triangle is a polygon with 3 sides, 3 angles, and 3 vertices. The sum of its interior angles is always 180 degrees. We classify triangles in 2 ways, by sides and by angles. Classification by sides. Equilateral triangle, all 3 sides equal, all 3 angles equal, each 60 degrees. Has 3 axes of symmetry. Perfectly balanced. Isosceles triangle, 2 sides equal, the legs, 1 side different, the base. The 2 base angles, that the ends of the base, are equal. Has 1 axis of symmetry. Scaling triangle, all 3 sides different, all 3 angles different. No axis of symmetry. Classification by angles. Acute angle triangle, all 3 interior angles less than 90 degrees. All angles acute. Right angle triangle, 1 angle equals exactly 90 degrees, with the right angle. The side opposite the right angle is the longer side, called the hypotenuse. Obtuse angle triangle, 1 angle is greater than 90 degrees, obtuse. A triangle can only have 1 obtuse angle, because if 2 angles were obtuse, their sum would exceed 180 degrees, impossible. A triangle can belong to both classifications simultaneously. For example, an isosceles right angle triangle has 2 equal sides and a 90 degrees angle. Fundamental property, angle sum of a triangle equals 180 degrees. Proof, by parallel lines. Draw triangle ABC. Through vertex A, draw a line parallel to BC. Call the angles, angle BAC equals X, at vertex A, angle ABC equals Y, at vertex B, angle BCA equals Z, at vertex C. The line through a parallel to BC creates alternate angles equal to Y on the left of A, and Z on the right of A. The 3 angles at A on the straight line are, Y plus X plus Z equals 180 degrees, angles on a straight line. Therefore X plus Y plus Z equals 180 degrees. This proves that in any triangle, the 3 interior angles sum to 180 degrees. Exterior angle theorem. An exterior angle of a triangle is formed by extending one side of the triangle. Theorem: the exterior angle of a triangle equals the sum of the 2 non-adjacent, opposite, interior angles. If the exterior angle is D, and the opposite interior angles are Y and Z, D equals Y plus Z. Proof: D plus X equals 180 degrees, straight line, and X plus Y plus Z equals 180 degrees, angle sum of triangle. Therefore D equals Y plus Z. This is enormously useful for finding unknown angles. Properties of special triangles. Equilateral triangle. All 3 sides equal, let each side equals A. Perimeter equals 3A. All 3 angles equal 60 degrees. Height, altitude, equals, square root 3/2, where is almost equal to 0.866 A. Area equals, square root 3/4, A superscript 2. It is also acute angled. Isosceles triangle. 2 equal sides, legs, each of length A, base of length B. 2 equal base angles, let each equals alpha, apex angle equals 180 degrees minus 2 alpha. Axis of symmetry bisects the apex angle and bisects the base perpendicularly. Height to base equals square root of the superscript 2 minus B/2 superscript 2 from Pythagoras. Right angle triangle. One angle equals 90 degrees. The other two are complementary or sum to 90 degrees. Sides. The hypotenuse, C, is opposite the right angle and is the longer side. Pythagoras theorem, C superscript 2 equals A superscript 2 plus B superscript 2, hypotenuse squared equals sum of squares of other two sides. This is introduced here, fully developed in term 3. Special cases, 3, 4, 5 right triangle, C equals 5 when legs are 3 and 4. May 12, 13, August 15, 17. Area equals 1/2 times leg 2, the two legs are the base and height. 3 examination questions. Example 1, in triangle PQR, angle P equals 48 degrees and angle Q equals 73 degrees. Find angle A. What type of triangle is it? Angle A equals 180 minus 48 minus 73 equals 59 degrees. All three angles are less than 90 degrees, it is acute angled. Checking sides, all angles different, it is scaling. Example 2, an exterior angle of a triangle is 130 degrees. One of the non-adjacent interior angles is 55 degrees. Find the other non-adjacent interior angle and the third interior angle. Exterior angle equals sum of non-adjacent interior angles. 130 degrees equals 55 degrees plus other. Other equals 130 degrees minus 55 degrees equals 75 degrees. Third interior angle equals 180 degrees minus 55 to 75 degrees equals 50 degrees. Check, exterior angle, 130 degrees equals 55 degrees plus 75 degrees equals 130 degrees. Angle sum equals 55 plus 75 plus 50 equals 180 degrees. Example 3, an isosceles triangle has a base angle of 38 degrees. Find the apex angle and classify the triangle. Base angles are equal, so both base angles are 38 degrees. Apex angle equals 180 degrees minus 38 to 38 degrees equals 104 degrees. Since one angle, 104 degrees, is greater than 90 degrees, it is obtuse angled. It is an isosceles obtuse angle triangle. 3 common mistakes. Mistake 1, thinking an obtuse triangle can have two obtuse angles. The angle sum is fixed at 180 degrees. One obtuse angle already exceeds 90 degrees, there is not enough room for a second. If one angle is 100 degrees, the other two must sum to 80 degrees, both must be acute. Mistake 2, confusing the exterior angle with its adjacent interior angle. The exterior angle and its adjacent interior angle are supplementary, sum to 180 degrees. The exterior angle equals the sum of the two non-adjacent interior angles. These are different. Mistake 3, applying Pythagoras to non-right angle triangles. C superscript 2 equals A superscript 2 plus B superscript 2 only works when C is the hypotenuse, the side opposite the right angle. If there is no right angle, the theorem does not apply. Well done. Let us summarize. Triangle classification by sides, equilateral or all equal, all 60 degrees, isosceles, two equal base angles, scaling, all different. By angles, acute, all less than 90 degrees, right-angled, one equals 90 degrees, hypotenuse is longer side, obtuse, one greater than 90 degrees. Key theorem, angle sum of any triangle equals 180 degrees. Exterior angle theorem, exterior angle equals sum of the two non-adjacent interior angles. Equilateral triangle, all sides equal, all angles 60 degrees. Isosceles, two equal sides, two equal base angles. Right-angled, Pythagoras, C superscript 2 equals A superscript 2 plus B superscript 2. For homework, A, in triangle ABC, angle A equals 2x plus 10 degree, angle B equals x plus 20 degree, angle C equals 3x minus 6 degree. Find x and all three angles, then classify the triangle. B, an exterior angle of a triangle is 112 degrees. The two non-adjacent interior angles are in the ratio 5:3. Find all angles of the triangle. Attempt a quiz on your LMS. Keep studying hard. Visit LightTech Academy at academy.lightech.com.ng for more NERDC-approved lessons from JSS 1 to SS3. Powered by LightTech Solutions Limited. Until next time.